Machine learning is not hard. It's like driving a car. You don't need to build an engine from scratch. Somebody much smarter already did that for you. You just have to learn to drive. It's no longer a nice to have, it's a must have. You can either invest the time to learn it now or become obsolete. The choice is yours. Learn machine learning now, and in no time you'll be building trading robots, creating AI assistants, and optimizing resumes to match job description, among many other use cases. By 2030, not knowing AI ML is going to be like not knowing Excel in the 2000s or calculators in 1980s. You've probably seen machine learning tutorials on YouTube with thousands of lines of code. But 95% of that is just data downloading, cleaning, and manipulation, which you can easily do in Excel. In this video, I'll handle all the data prep in Excel and use less than 15 lines of code to build a machine learning model. So with no more shenanigans, let's start busting some of the biggest myths about machine learning. Myth number 1. You need to be a data scientist or a math genius. No, you don't. You don't have to be an Einstein or a Newton. With auto machine learning, you don't have to write the math behind the model. Someone much smarter already did that for you. You just have to use it. Myth number 2. Machine learning needs expensive hardware. No, it doesn't. You don't need a secret underground AI lab with thousands of GPUs. A simple laptop is enough. Unless you're trying to create the next ChatGPT. So don't let anyone convince you otherwise. Myth number 3. It takes weeks to build a machine learning model. No, it hardly takes a few minutes and just a few lines of code. In fact, let me show you these 2 lines. These 2 lines are it. This is machine learning. The first line, model.fit, or in some cases it's model.train, takes input variables, you specify an output variable, define some parameters, that is it, and then you train the model. And in the second line, the model starts predicting. A lot of the times when you watch videos on YouTube about machine learning, you see 500, 600, maybe 1000 lines of code. But most of that is actually pulling in data from the source, performing cleanup, doing transformations, while the actual machine learning code is just a few lines. Before we jump into coding, I do want to spend some time on introducing the basic concepts of machine learning. And as we go along the course, I will keep on introducing some theoretical concepts, which in my opinion are important for the audience to know, but in as simple terms as possible. So broadly speaking, there are 3 types of machine learning. Supervised learning, which is the focus of our course. So whenever I talk about machine learning, just assume I'm talking about supervised machine learning. The other 2 are unsupervised learning and reinforcement learning. And since they are not the subject of our course, let's put them aside and turn our attention back to supervised machine learning. Well, what is it? How does it work? In simplest of terms, it's just fancy regression. Now, I'm sure you would have seen something like this in your study years, where you have an x-axis and a y-axis, and data points are plotted in purple color. There's a function, which is in dark green color here, which predicts the value of y given the value of x. And the best function is the one which minimizes the error. Now imagine this in 3, 10, 50, 100 dimensions. Each input variable in supervised machine learning becomes a dimension. So simply put, supervised machine learning is multivariable, multi-dimensional, and non-linear regression. It's fancier than your run-of-the-mill linear regression, but the core idea remains the same. Now, as I showed in this diagram and the 2 lines of code that I showed earlier, we need to specify the input variables or x and the output variable or y. We need to provide this information to the model. Now, to keep this video extremely simple, I've cut all the noise, have downloaded data, and calculated technical indicators in Excel. I did this because I absolutely do not want to perform any data pulling, data calculations, data manipulation, or transformations in this video because it unnecessarily complicates the code. Now let's start with this EuroGBP file. I have already downloaded data, and the data is from 2009 all the way till 2025, which is the latest data. And I've basically downloaded the data on the 4-hour time frame. Now next what we need to do is we will only keep the columns that we need. So I am deleting all the other columns other than closing price and the 3 indicators. And the three indicators that I'm using here are 20-day moving average, 200-day moving average, and 14-day RSI. I'm bringing the close to the final column because this will be the predicted price. So now here, these three columns in yellow are the input variables. So we will give the model these three inputs and we will ask it to predict the closing price. Now, one important thing is that for this candle, this was the closing price and we actually want the model to predict the next closing price. So we will change the name of this column to next close and we will delete this value and shift cells up so that it starts to predict for the next column. And since the last one doesn't have any data now, I will just delete it. Now we have 25,000 rows of data, 25,000 plus 1, but the first row is the header row. So we exactly have 25,000 rows of data. Now, one important thing that we need to do is that we need to split our data into training data and test data. What does that mean? So for example, if we have 100 rows of data, we do not train the model on all 100 rows of data. We only train it on 80 rows of data. And then we give the remaining 20 rows of data as new data to the model so that it can start making predictions on those new 20 lines of data that it has not seen. And we can actually see the accuracy of the model based on the predictions that it makes for the remaining 20% of the data. So let me summarize it one more time. We give the model 80% of data and we train it on 80% of data. Once it is trained, we give it the remaining 20% data, ask it to make predictions and see how accurately it is making the predictions. So now, in our case, we have 25,000 rows of data. We will split it into two data sets, training data and test data. I will keep 20,000 rows of data in training and I will keep the bottom 5,000 rows of data in test. Now, ordinarily, everything that I'm doing here, deleting columns, renaming them, all of that should happen in Python. But because I don't want to overcomplicate the code, at the moment I'm doing all of that in Excel. Now what I will do is everything after row 20,000, I will just delete it and this becomes my training data. So 20,000 rows of data, including the header row, becomes my training data. And for test data, I will delete the top 20,000 rows and keep the bottom 20,000. So here I will go to 20,000, delete all the rows at the top, and now I have data all the way till 5,000. So the bottom 5,000 rows are for test data. Now our training and test files are ready and it's time to start coding. The first thing that we need to do is import libraries. So the two libraries that I will import are XGBoost and Pandas. Now let me explain what these libraries do. XGBoost is the machine learning model that we will be using, and Pandas in Python is sort of like an Excel sheet within Excel, so it stores two-dimensional data. And I will actually show you how Pandas stores data, and the Excel sheet that we've created, we will pull that Excel file using the Pandas library. So I pasted these two lines. Let me click on the run button, and once it shows this check mark, it means that the code was run successfully. Now let's bring in the data that we had stored in Excel into Python. For that, we will use the read CSV function, pd.readcsv, and pd is actually Pandas. You can see here that we use the command import pandas as pd. Now wherever we mention the words pd, that means Pandas. Pandas will read the CSV file that we had stored earlier, and this is the path of the file. And it will store it in train data variable. Similarly, we will do the same thing for test data. Remember, we had created two files, one for training and one for testing. So the training CSV data will go into train data variable and the test data will go into test data variable. Now let me run it. And here you can see that we do have two variables now, test data and train data. If I click on it, you can actually see how, let me turn off the insights so it's more visible, how all of that data, 20-day moving average, 200-day moving average, 14-day RSI and next period close, the CSVs that we have created, have now been pulled into Python. And there are two different data sets. The first one is training data and the second one is test data. If I go into training data, you can see that we have 20,000 rows of data. And similarly in test, we should have 5,000 rows. So that's exactly what we had expected. Now, as I had mentioned earlier, once we have the data, we need to split it into input variables and output variables. Basically, we need to tell Python or machine learning model what are our inputs and what is going to be the output that the machine learning model needs to predict. So for that, I will again create two variables. First, from training data, I will specify which columns I want to treat as X. And basically, I want to treat everything as X or input value other than the next close column. So I'm using training data dot drop, which means that I'm dropping one column and that column is next close. And Y, which is the output variable, is basically that next close that we had seen earlier. So now we have split our training data into input variables and output variables. Let me run it. Okay, so this check mark again shows that we have actually run this successfully. Let me show you Xtrain here. If I go into Xtrain, and again let me hide insights, you can see that I only have three columns: 20-day moving average, 200-day moving average, and 14-day RSI. I do not have the next period's closing price. And similarly, if I look at Y training, Y is the output variable, then you will just see that I have next close, nothing else. Now let me quickly do the same thing for test data. I will click on run, and again in test data we should have 5,000 rows of data. Let's quickly have a look. So for Y test we only have next close and we have 5,000 rows of data, and similarly for X test we should have 5,000 rows of data and those three indicators that we are using. Now if you look at it, we have written like 5, 6, 8 lines of code so far, and even this code had nothing to do with machine learning itself. We just imported the data, the two CSV files that we had created, and we split them into the input variables and the output variable. That's all we did. And here I again want to emphasize one more time that this is that same graph X and Y that we had seen earlier, but in this case we have 3 X variables and 1 Y variable. So it's sort of like a 4-dimensional regression. Now we actually come to the model training part. What we're defining here is that model, we will use the XGBoost model, XGB regressor. And N estimators means nothing more than I want the model to do 500 rounds, and we will actually see that it will do 500 rounds of training. And this is that model.fit line which I had shown in the beginning, and we are defining X and Y variables here. We are telling it that hey, training data is this data, these are all the inputs variable from the training, these are all the output, in this case it's just one, the output variable from training data. And we also tell the model what is the test data as X and Y, because this will be used for evaluation. So this is the evaluation set. Evaluation means that this outputs RSME, which is root square mean error, is what the model will try to reduce. Now, when I was showing you the graph earlier, I had mentioned that the purpose of the model is to reduce the error. And the error will be reduced based on the performance on the test data. So model will train itself on the X data, then evaluate its performance on test data. So now let's run, and we will actually see those 5,000 rounds, and you can see how quickly this happens, right? It hardly took what, less than 10 seconds for this to be done. And the root square mean error, which is again the same error that I was showing you on the graph, is 0.002. At this point, let's not worry about what it means. We will see in subsequent videos what it means, how to optimize it. But what I wanted to show is that just with a few lines of code, we've hardly written like 10 lines of code, and you can actually train the model. And with supervised learning, the most important thing, or the only thing that you need to learn, is that you need to tell the model that, hey, these 3, 4, 5 are my X variables. This one variable is my output variable, and the model learns itself. So that's all you need to do. Now that we've trained the model, let's use this to start making predictions. Now, I am asking the model to predict, modic.predict, and I'm giving it the X values, the input variables of the test data, and it will predict the Y value itself. And that value of Y that it predicts, I am saving it as Y predict close. So let's run the code. And when we come here, Y predict close, we actually see that it has predicted the values. If I hide the insights, so these are all the predicted values for each row of data that we had given it earlier. Now, if you want to compare it with the actual data that we have, let's do that. So I will add 2 lines of code here. First is in the original test data, I will add a column called predicted close and I will pass on the value of this variable. And then I will save this new file as test with predictions, and then we will be able to go and match the actual predictions with the original result. So let me run these 2 lines of data. These 2 lines of data have also run successfully, and this CSV should now be saved. Let's go and check it. So now you can see that this test with predictions file is saved here in our folder. If I open this file, you see that we have both the original, this is the next close that was there originally, and this is the predicted price. In fact, let me zoom in a bit for everyone's benefit. And this was the original closing price and this is the predicted price. Of course, there is some difference, and at this point we are actually not concerned with the accuracy of the model. I just wanted to show how easy it is to use machine learning. And today, I think with less than 15 lines of code, we have trained our first machine learning model. So let's recap. We learned that supervised machine learning is just fancy regression. All we need is to give input variables and output variable to the model and see magic unfold. I congratulate you on building your first machine learning model. Will the model give great results straight away? Absolutely not. But it's like baking your first cake. It's probably going to be a disaster. That's okay. The goal is not perfection, it's progress. And we have a long way to go. In my next video, I will show you how to import data and calculate indicators within Python. So you won't have to do the calculations separately in an Excel sheet like we did today. Then I will start going into some of the more nuanced concepts like feature engineering, overfitting, underfitting, data leakage, some of the popular machine learning models like AdaBoost, ARIMA, Random Forest, regression, classification, hyperparameter tuning, and to top it all off, ensemble models on top of one another. I would highly encourage that you watch the entire video because each subsequent concept will build upon the last one. So if you miss something, you might get flustered. Thank you for watching the video, and may your code always be clean, your charts green, and your profit supreme. Bye bye.